Hello everyone, my name is Lou Del Monte. Welcome to Del Monte on Science. Today we're going to discuss the mystery of dark matter. And this has been a significant mystery since about 1933. So I'm going to take you through a little bit of the history. It starts in 1933, and just as a point, I discussed this fully in my new book, Unraveling the Universe's Mysteries, available at Amazon and Barnes & Noble online. So please avail yourself of a copy. In 1933, what happens? What do we see? Well, at the California Institute, 1933, Fritz Zwicky, Z-W-I-C-K-Y, he makes measurements of galaxies. Now, ours is a spiral galaxy. You could draw a galaxy looking like this, and it's made up of stars, and and so forth. And it's believed that our galaxy has a huge black hole in the middle of it, and so on. But another depiction of the galaxy, a spiral galaxy, is that it has arms like this that go around. Okay, and that's a little bit better picture of what the galaxy looks like. It's a spiral galaxy. And I'm not saying it has this many arms, but that's the basic idea of a spiral galaxy. And what does he discover? And for a moment now, I'm just going to use the circular representation. He discovers that the stars out here, which are way out, let's assume the Earth is around here someplace. So this is Earth. That the stars in the outermost portion of the galaxy, as they are doing their orbit in the galaxy, the galaxy is actually orbiting. As they rotate, these stars are rotating too slowly. Let me start again. They're rotating too quickly. Okay, a star, in order for it to be held in place by the gravitational mass of the galaxy, would have to rotate slower, because when it rotates fast, the centrifugal force would tend to throw it into outer space. So Zwicky takes a look at this and he says, that's odd. This star is rotating at the same rate as that star, and inner stars are rotating at the same rate as the outer stars. And this incredible discovery he publishes, and he estimates that the only way that this could be the case is that there has to be more mass than we can see. Okay, that there's now the name dark matter hasn't really crept into the public consciousness, but he's saying that for that star to be actually rotating so slowly, there has to be more mass in the galaxy than we can see. And you would think, and he estimates, his estimate is that there's 400 times more mass. 400 times more mass than we can see. Okay, so now the fact that we can't see it, you probably are getting the idea of why people eventually call this dark matter, why we don't see it. Okay, you would think the world of science would be, from this one discovery, just irrevocably changed. But in reality, just about nothing happens. Nobody goes AWOL and writes more papers and it becomes a furor or anything like that. However, okay, now fast forward from 1933 to 1975. Okay, so we're fast forwarding now, 1933 to 1975, and a young astronomer, Vera Rubin, okay, Vera Rubin, and her colleagues, her fellow staff member, and she was working with Ken Ford at the time. They were astronomers at the Department of Terrestrial Magnetism at the Carnegie Institute of Washington. And they present the same findings that Sawicki did, except they're using a new sensitive spectrograph, which essentially measures the wave, separates an incoming wave into a frequency spectrum, all right? And this new spectrograph is very able to accurately measure the velocity curve of the spiral galaxies. And they found that essentially the same phenomena. They found that the stars, I'm doing the circular thing, the stars at the outer edge of the galaxy were rotating at the same speed as the stars at the inner edge of the galaxy, and this made no sense because if there was nothing holding them there, the centrifugal force of this outer star moving so quickly would have thrown it into outer space. Now the term dark matter comes into the consciousness of the scientific community and leaks from there to the general population. We finally get a name for this phenomena, and it's called dark matter. And why is it called dark matter? Well, we can't see it. It doesn't emit or absorb light. But what does it do? We have found there's a term in science called gravitational lensing. And that's when light, let's say you have a massive star and you have light coming from another massive star. When light is coming from a massive star, and instead of going in a straight line, I'd like to draw this star just a little higher. Instead of going in a straight line, the star actually pulls it down. And that's gravitational lensing, okay? It's causing light, gravity is causing light to actually be manipulated and attracted. And so they find from gravitational lensing that dark matter is real. And they do the experiments and they find out, now I'm going to draw a couple of galaxies. Here's our Milky Way galaxy, etc. Here's the Andromeda galaxy. That's a close sister galaxy. And this is the Milky Way. This is the Andromeda. Okay, what they find out is there's an aura of dark matter within and around the galaxies. So dark matter is within and around the galaxies. So it's an aura around this galaxy. But in between galaxies, no dark matter. They find no dark matter between galaxies. So what does the dark matter look like? It looks like it's a glue of some sort, okay? And what is it doing? Well, it seems to be holding the galaxies together. And you know, I've discussed in other posts that actually it makes the galaxy act like a single mass rather than a collection of celestial bodies. In the next post, we're going to discuss exactly what is dark matter. What is the theory about dark matter? And so this is the foundation video talking about the discovery of dark matter. And now we'll get into the science of dark matter in the very next post, part 2. Thank you.